Did you ever wonder how wind chill temperatures are calculated? Let's investigate. This is a video for teachers to assist in using the wind chill temperature activity with their students. If you would like to obtain the entire activity, go to this bit.ly website. Notice the name is case sensitive. Press pause if necessary. This is a copy of the wind chill activity for the TI-Nspire. This is the student worksheet or gift. I don't want to read the whole thing because you can get that, but I do want to explain that wind chill is the term used to describe the rate of heat loss on the human body resulting from the combined effect of low temperature and wind. And it goes on to describe this. This is a formula in a function in two variables right here, pretty complicated, where WCT represents the wind chill temperature in degrees Fahrenheit, T represents the actual temperature in degrees Fahrenheit, and W represents the speed of the wind in miles per hour. So this is the formula that we're going to be using here. This activity is divided into two parts. There's a whole class activity that we do with the class, and there's an individual student or pair of student activities that you can either do in class or assign for homework. Number one, using the information above, create a table of wind chill values for an actual temperature of 40 degrees Fahrenheit and the wind speeds from 0 miles per hour to 50 miles per hour in increments of 5 miles per hour. Round each answer to the nearest degree. Now we're going to go to Nspire and show you how you can do this a couple of different ways. Let's look at the TI-Nspire document. This is the title page right here. Next page is a picture that I took, snowy afternoon in Poland, Ohio, here where I live. This explains what wind chill is. We talked about that. And this is the formula as a function of two variables. And it explains about how wind chill temperature is only defined for temperatures at or below 50 degrees Fahrenheit and wind speeds above 3 miles per hour. So we do need to know that. So if there's no wind or wind less than or equal to 3 miles per hour, the wind chill temperature is the actual temperature. So here we're at number one. So using that formula, we want to create the table of values on paper for 40 degrees actual temperature and 0, 5, 10, 15, up to 50 miles per hour. All right, so I'm going to go ahead and insert a calculator page. Now one way would just be to type in the formula with the numbers in it. So I can just go ahead and type in 35.74 plus the 0.6215 times the temperature, which was 40, minus, and then 35.75 times the wind, which will go with 5 miles per hour starting, because 0, there's no wind chill effect there, so I'll just go with my 5 miles per hour. And we're going to raise that to, according to the formula, 0.16 minus, I'm sorry that we did the minus, plus 0.4274 times the temperature, 40, times that wind, which is 5 miles per hour, again raised to that 0.16 power. And press enter. And to the nearest whole number, that would be 36 degrees. So at 40 degrees outside, 5 miles per hour wind, the wind chill would be about 36.5 degrees, or we'll just go with 36 to the nearest whole number. Now what I could do is just go ahead and copy and paste that down and then edit this. So I could go back up and then edit this and change the 5 to a 10 and so on. That would be one way to do that. But I'd like to show you a different way that I think is more clever. The second way is I'm going to go ahead and create or define, using menu, actions, and define is the first one. I'm going to define a function called WCT, and it's going to be a function of two variables, T for temperature and W for wind. And then I'm just going to type that formula that was given to us at the NOAA website. Times W. Notice I'm putting in the variables, not the values. And then plus the final one. And I have to multiply it times the temperature and times the wind raised to that 0.16 power. And I'm defining that function. Now to evaluate it, all I have to do is type in WCT, wind chill temperature, as a function of, and I said, I think we went, let's just do the one we did before, 40, and then comma, I think we went 5 miles per hour, right parentheses, and enter. And that's our answer. And now to get the other ones, I can just go up and copy and paste it down, go through and delete the 5, make it a 10, then make it a 15, make it a 20, 25, 30, and so on. So that would be a very nice way to do that using function notation from TI-Nspire. Please press pause as needed. Part 2 says on the next page to create a spreadsheet with the data that we calculated. Instead of typing it in by hand, I'm going to show you another way you could have done this. See if you like that or not. To put in the wind, I could have typed in 0, 5, 10, 15, 20, 25, and so on up to 50. Instead, I chose to use the sequence function. So I said let in the equals row, the second row, I typed in equals sequence of, it's 5x is the expression, comma x is the variable I used, start with 0, go to 10. So I went 5 times 0, 5 times 1, 5 times 2, 5 times up to 10. So that's where I got that one here. Instead of typing in the numbers that I calculated before, I typed in the 40 here because when it's a 0 wind, it's the same as the outside temperature. But to get this one, notice I use the WCT function of 40, comma, whatever's in A2, and I ask to round it to 0 places. And once I typed that in, I did a fill down, and so a fill down, what it did is it filled this so that it made this A3. It was still doing all the same things, but with A3, then A4, and A5, and so on, up to A11. So there's another way, except for instead of typing it in, there's another way that you could have got your data into the spreadsheet. Press pause as needed. Number 3 asks us to create a data and statistics page and plot wind along the horizontal and wind chill along the vertical axis. So when you get there, I created that page, and I'm going to plot the wind along here, kind of cool there, and the wind chill here. And so those are my points. And now I want to go ahead and find the regression equation that best models this data. And when you're in data and statistics, you just go over to the menu under Analyze and Regression. And I think I'll try an exponential first. And it does it right away. And you can see that the exponential looks more linear than exponential. So that wasn't a very good one. So let's maybe try another one. I thought maybe quadratic might be a good one to try. And that's a little bit better. But finally, when I tried a quartic, I think that was the best one. And so let's go ahead, and there's the quartic. And let me get rid of these. And I would say that's probably the best one there, that quartic. Part B says, describe how the graph seems to fit the data pretty well. And then it asks about interpolation and extrapolation. So pause is needed. Here in number 4, we found the regression equation. It says define a function w of x that is the same as a regression equation. And that regression equation is stored in stat.regression equation. So I'm going to go ahead and go to this calculator page and use that define tool, define function again, w of x. And under the var menu, I have all the stat variables, and I want the stat regression equation, and I need a argument there, which would be x. So now whatever equation we had in this graph here, and let's just go ahead and show that right there, is now stored, that fourth power equation is now stored in w of x so that I can access that. There are 4 questions in part 4. 4A and B we've already done. C is it says to find the wind chill at 12 miles per hour. So I'm going to use what's called a math box. Control M allows me to have a math box. And I'll type in W at 12, press enter, and it calculates it for me. And then I can do another math box and calculate W at, was it 50 or 660 inside the math box. I'm in a notes, but if I use the math box, it'll do calculations for me. And the answers will be, and explanations are posted later. Part 5 says go back to the spreadsheet, and in column C, and in the second row, the equals row, type equals round this to 0 decimal places, W at the wind values, and press the enter key. Compare the answers in B and C for each row, describe what you see. Now this may seem a little confusing, so let's go back. And it said in this row, type in equals. We want to round our answer to 0 decimal places. And I want to take that function W, which was our regression equation, and evaluate it at each of these numbers in the wind column, W-I-N-D. And when I hit the D, watch how it goes bold, meaning it already is a variable. And I want to round that comma to 0 decimal places. So round that regression equation at each one of these numbers is 0 decimal places. Now remember, this was calculated from the NOAA formula. Now we're using our regression to see how close our regression equation was to these values. So let me go ahead and press enter. And you can see the values look exact. Pretty amazing. They're not always going to be that perfect, but that time they were. Now that we've completed the whole class activity, each student or pair of students will be assigned his or her own problem. It's very similar to what we just did. So here's the individual student activity on the Nspire in that file. Has all the directions there as before. But to help you out, I created a wind chill activity solutions file as well that you have. The students won't have this. And all the answers are in red. So as you can see, these are things that we've already done. But here are the answers to what we just did here. And the answers to 4, A, B, C, and D are in red. And for the individual activities, I did the 30-degree one and showed all of the different answers. But for the other ones, I only showed the regression and the table. So here's for 20 degrees, 10 degrees, and so on. And I think I went every 10 to maybe minus 30. Yeah, I think that's it. So again, if you're interested in obtaining the entire activity, this is the website, the bit.ly website. It is case sensitive. And this concludes the video.